Now we're going to graph inequalities. So if you, like I said, if you don't remember graphing, I'm going to go over that. The first thing you do with an inequality is you take it and make it an equation. Y equals 5 over 2x minus 4. Then we're going to graph that equation. Okay, so maybe you'll remember y equals mx plus b. So one way to graph, there's like 3 ways to graph an equation, a linear equation. One way is to use the slope and the y, what we call the y-intercept. So in our case, our slope is 5 over 2. Oops. And our y-intercept is the point 0, negative 4, meaning that I'm not going to have, if I put 0 in for x, I'd get negative 4. And we start with the y-intercept, we graph that. So 0, negative 4 is going to be like right there, okay? So it's on the y-axis. This is the x-axis, this is the y-axis. And so we're graphing that ordered pair, which is the y-intercept right there on the y-axis, 0, negative 4. Then we can use the slope to count. Maybe you remember rise over run. So you're going to count up 5. So 1, 2, 3, 4, 5, and to the right 2. And you can keep doing that. Up 5, 1, 2, 3, 4, 5, and to the right 2. And then I'm kind of out of room, but that's 3 points, so that's nice. And then we're going to draw a line in a minute. We're going to draw a line that connects those points. Now, one thing you have to check is in the original, if it's a less than or a greater than, you're going to use a dotted line, meaning it doesn't include the line. But if it's less than or equal to or greater than or equal to, you'll do a solid line. So you usually want to check that before you draw it so you don't have to erase later. But because it's just a greater than, this is greater than, we're going to use a dotted line. So, and then the ruler helps. Okay. And there's our line. Now that's the boundary line that we were talking about. So now we have to pick a point, not on the boundary line. Any of the other points just can't be on the line. I usually pick 0, 0, so I'm going to choose 0, 0 because it's not on the line. And I plug it into the inequality here to see if it's true. So 0, see if it's a solution, is greater than 5 halves times 0 minus 4. And then I have to do the math. So 0, 0. So I get 0 is greater than negative 4. And then I have to stop and say, is that true? Is 0 greater than negative 4? Yes, that is true. So that means we're going to shade the point 0, 0. So here's the point that we tried, 0, 0, and it worked. So we're going to color all of this area over where that point is. It's like volleyball. That point 1, so that person that hit the ball, 0, 0, they got the point. And so the whole team gets the point. Now, if you had picked another point somewhere over here in the white area, that point would not have worked. So then you would have said, okay, not this side, the other side. So think, you only have 2 sides to the line. The one side works and the other side doesn't. Okay, so hopefully that helps. If not, we're going to do another example. It takes a couple examples to kind of get the hang of this. Okay, so graph the linear inequality. Okay, first thing I do is make it an equation. 2x minus 3y equals 6. Now, if you don't like graphing using the slope and intercept, that's the way I like to graph a lot of times, but you don't have to. You can use what's called the intercept method. And in the intercept method, what you do is you find the x-intercept and you find the y-intercept, and you graph those points. So it's kind of like you make a table of values, and you choose x for 0, and you choose 0 for x, and you choose 0 for y. That'll give you 2 points. Now, we like to have 3 points when we're graphing a line, but we'll do these 2 first. Okay, so if you plug in 0 into the equation, 2 times 0 minus 3y equals 6, you get negative 3y equals 6, or y equals negative 2. So that's an ordered pair that works, 0, -2. Now let me go ahead and graph that point, 0, -2, which is right there. That would be the y-intercept. Okay, now we're going to switch and find the x-intercept. We're going to put 0 in for y. So 2x minus 3 times 0 is oops, we're doing the equation. Erase that. Equals 6. So 2x is equal to 6. Or if you divide by 2, you get x equals 3. So when y is 0, you get x equals 3. Now that ordered pair is 3, 0, so you go right 3, 0. And right there is another point. Now, what would be another good point to choose? Well, you kind of get to pick, but I'm going to pick 6 for x and see what happens. So we'll see if I have a good pick. 2 times 6, and I'll tell you why I picked that in a minute, minus 3y equals 6. So I get 12 minus 3y equals 6. A little more room. So if I subtract 12 from both sides, I get negative 3y equals negative 6. Oops, negative 6. And then if I divide by negative 3, I get y equals 2. Okay, so then I can plot the point 6, 2, which is going to be right here. Now the reason I picked 6, I can kind of see what the slope was from my first 2 points. So I thought, well, for a third point, I think the good one's going to be at 6. Now you don't have to. You could have picked 1. You could have picked negative 6. Pick any number you want that's going to fit on your graph paper. You know, I was trying to avoid fractions. Okay, but you can graph the fractions. You just kind of have to estimate it. Okay, so I've got 3 points. Now I have to decide solid or dotted. Solid line or dotted? Well, this time it's going to be dotted because it's a less than symbol. So I'm going to put a dotted line. Try to do that straight. And now I have to pick a point not on the line and see if it's true or if it's false. So I'm going to pick 0, 0 again. It's my favorite point to pick. So I'm going to take my inequality, 2x minus 3y is less than 6, plug in 0 for x and 0 for y, and see if I get a true statement. I get 0 minus 0, which is 0. Is 0 less than 6? Yes. So it was true, and that means I'm going to shade all of this over here. Because the point I picked, which was right there, and you can't see me do that, but it was that 0, 0 point, that one worked, okay? And you could have picked another point. I mean, just to show you, what if I had picked like 5, negative 5, 1, 2, 3, 4. What if I had picked that point, 5, negative 5? Well, I could put it in 2 times 5 minus 3 times negative 5, and it is not going to be true. I'm going to have 10 plus 15 is less than 6. No, 25 is not less than 6, so no. So I knew that point wasn't going to work because it's not in the shaded area. But you don't know when you're picking the point if your point's going to work or if it's not going to work. If it works, shade that side of the line. If it doesn't work, shade the other side of the line.